So I recently went through the process of creating a genetic algorithm, which is a primitive form of AI. Well, maybe not primitive, but it's one of the more simple forms of AI, which creates methods for me. So what I did was I got it to go through a few thousand possible methods using the genetic algorithm AI stuff, and got it to generate essentially the method it thinks is best, at least with respect to one thing, which in this case I used move count for. And, well, it gives this output, which just essentially means it tells me the subset which it thinks is best, which it thinks is the shortest in terms of QTM. And as you can see, this does converge very nicely for each of these, and the top four are all exactly the same. The next few are as well, but they're not as good, at least going by these measurements. And this means that the method which my genetic algorithm, the primitive form of AI, found, is probably also the first AI-generated method, because all the other ones that I've seen just solve the whole cube or solve according to preset methods, is this. So this is what it looks like after. This is the position you're meant to solve to as your first step, and then the second step is apparently really short. So yeah, it looks weird, doesn't it? So what it says is these two have to be solved. These two have to be solved. These two don't have to be permuted or oriented. These two need to be permuted. So yeah, it's weird, definitely. So well, I'm going to draw a few conclusions from this. Firstly, just from the data itself, it does show that each of the it does converge on certain solutions, and also it considers solutions which a human might not necessarily consider, which is definitely very interesting, if a little weird. So yeah, there's this weird checkerboard pattern, isn't there? So let's get the first question that everyone's going to be asking out of the way. Is this actually useful for speed solving? Well, that depends on two things. Firstly, and now I'm not a 2x2 solver by any means, so I'm going to ask, is it easy to get to this position in speed solves? And secondly, how ergonomic are the algorithms? Now, I might incorporate that into a future version if I ever get around to it, but I can't get access to the CubeSolve database at the moment, so if anyone knows where, how I could do that, that would be very useful. But yeah, so apparently this averages basically 10 moves in optimal QTM, which is interesting because I would have thought something like this maybe would be faster. So yeah, this does seem to lend itself to quite a few tricks. You can definitely reduce the alg count by a fair bit by implying some of those tricks. So here, if you line up those columns, say, or if you line up those columns, say, so it might actually be more feasible to line up to two columns and then solve and so on. And also, it depends, can you look ahead after you solve to this position? Because it doesn't seem as easy as, say, with EG. But the program didn't converge on EG, so yeah, it's interesting, definitely. But yeah, I'll put a data dump down below with both the QTM and the HTM, just for you guys to look through. But I hope you were at least interested in seeing the first ever computer generated method, at least for 2x2. And well, we'll have to see if I ever get around to taking it higher to 3x3, 4x4, and so on.